Hi people, we are going to talk today about tangents in circles. So a tangent, and if you want to follow along, we're on page 732. A tangent it's a line in the same plane as the circle, so we're going to be staying in the same plane. It's a line that has exactly one point of intersection with the circle. So like this up here would be a tangent. Its tangent to the circle has one point of intersection, and that point of intersection, we call that the point of tangency. And it doesn't necessarily have to be a line that's tangent. It could be a segment, it could be a ray, but it's going to have exactly one point of intersection with the circle. So that's a tangent. We also could have a tangent that's like right here. We'll make it a nice ray. This ray is tangent to the circle. It has one point where it intersects the circle. So with tangent lines like these, or rays, you have something called a common tangent. And a common tangent, this is going to be a tangent that is tangent to two different circles. So for example, we can have a circle right here, and maybe a circle right here. And if you have a tangent that's tangent to both circles, like this, has a point of tangency, then it is a common tangent. Both these circles have that tangent in common. For these, you also would have a tangent like right here, point of tangency here and here, so they have those in common. And you also, there's actually two more here that we could point out, go in a different color. You'd have one like right here, and it would intersect at this one point here and here. And then similarly, it would go like, see if we can get this, like that. So this would have actually four common tangents between these two circles. And there's plenty of different like combinations you could have. You could have two circles that maybe have like, they touch one another right here. That would be a common tangent. They share that point. That tangent is for both of them. And then you also would have a tangent here, like this, and a tangent over here, down like this. Those are common tangents. And there is the possibility to have no tangents in common. So you have a circle like this, and then you have another little circle right inside. There is no tangent for this circle. That's going to be a tangent for the larger circle as well. Every tangent here is going to intersect the larger in two different points. And every tangent for the larger circle is not going to have any points where it intersects the smaller. So those are what common tangents are. We're going to talk about one theorem today, and then we'll be done for the day. So our theorem is on page 733. And this theorem says that in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. And what this is saying, you can use this a couple ways. We'll use their example. We have circle S here, and this is going to be our tangent right here. We'll call that point T, call this line L, just like they have. So what this theorem is saying is every line that's tangent to a circle is perpendicular to the radius. So if you draw the radius to that point of tangency, it's going to be perpendicular to that line. And also, if maybe you have like a line and you don't know if it's tangent or not, if that line or the radius is perpendicular to that line, you know it is tangent. It only intersects the circle at one point. So you can use it both ways there. There's a couple ways we can use this. Maybe we're checking to see if something is tangent to the circle, or if we know something is tangent, then we can use that relationship. So let's check to see if something is tangent. There's only one point of intersection. And we'll go ahead with right here, circle J, goes down to L, then over to K, and then it comes back to J. And we know some lengths for this. We know this is 8, we know this is 15, and we know this part right here is 9. And we want to check to see if this is a tangent, if KL is tangent. If it is tangent, then we'll have a right angle here, and it'll make this a nice right triangle. Okay, so in order to do this, in order to see if this is tangent, we're going to check to see if this is a right triangle. That's going to be the best way to go. If we have a right angle right here, we don't know if it's a right angle, but if this is a right angle, well then it's tangent. And in order to do that, we need to check if this is a right triangle. Well, one thing we should know, we have the radius of 8 here. Well, one thing we know about all radii in a circle is they're the same, so this right here should be 8. And if I kind of redraw what we have, we knew this was 8, that's this side, JL, and K. We knew KL was 15. And now we know KJ, well that should be 9 plus 8 is 17. And if you know your Pythagorean triples, you'll recognize this is a Pythagorean triple, so this should be a right angle. If you don't recognize your Pythagorean triples, then you'll have to go through the converse of Pythagorean theorem. You would do all this, but you will find out that, well, 17 squared, 289, when you end up squaring and adding these together, you get 289. So there we go, 289 equals 289. So this is a right triangle, meaning this is a right angle, which then we can conclude that KL is tangent to circle J. So that's one way you can use this theorem, is to check if a line, a segment, a ray is tangent to a circle, and you're going to make a little right triangle to test that. Another way you can use this is if you know something is tangent, then you know there's a right triangle, and we can use that to find missing lengths or missing measurements. So let's say, we'll do the example they have so you can follow along. Let's say we have, actually we'll do one of the ones on the bottom so you have an extra example. We'll do 3B. So we have in 3B, circle R, then we go to Q here, and then we go to S. And we are told in this one, we are told, let's see, no, that's not X. This is X. This is 2, and this bottom side is 4. And it says we are going to assume that the segments that appear to be tangent are tangent, so we're going to assume that QS is tangent. That's what we're told here. So if QS is tangent, well then it makes a nice right angle here. So we have a nice right triangle. And then to find our missing length, which is X here, we want to find the value of X, we can use this right triangle. I'm going to flip it around a little bit so we can see it this way. If we flip it around, we would have RQS with a right angle, and we know QS was 4. We know this was made up of X and 2, so this whole side is X plus 2. And then if we go ahead and try to figure out this missing side here, well that's also just a radius of the circle, so this should be X. Now with this we can solve for X. We have a right triangle, so X squared plus 4 squared equals X plus 2 squared. And then you're going to end up with, well, X squared plus 16 is equal to X squared plus 2X plus 4X plus 4, A squared plus 2AB plus B squared. And then we're just going to solve. So your X squareds are going to go away. You're going to bring your 4 over, so you're going to have 12 equals 4X, so you should get X is equal to 3. And that would be your solution here. Your missing value is 3. And if you wanted to know this whole side, it would be 5. It makes a nice 3, 4, 5 triangle. That worked out really well. Alright, so that's all we have for today. You can go ahead and practice some of these. That other example on 733 you can do. There's a step-by-step guide. If you're having a little trouble, you can go through their step-by-step guide. Otherwise, I'll give you some problems in the textbook to try. Alright guys, have a nice day.